Hi guys, Mrs. Suoja here. This video is going to cover section 3.1. We identify pairs of lines and angles. And before we do that, actually, we're just going to review some information you probably already know, such as parallel lines. These are my lines right here. They are chopsticks. So parallel lines are lines that never intersect, like a railroad track. Intersecting lines are lines that intersect at one point, but skew would probably be new to you. So here are the two requirements for skew. They never intersect, but they are not parallel either. So maybe pause the video and see if you can think about what kind of setup would allow you to make two lines that never intersect but are not parallel. Okay, I changed my camera angle. I'm getting fancy here, guys. Here is how you get two lines that never intersect but are not parallel. You have to take one of your lines and lift it like this. And these two lines are not parallel anymore, right? But they're never going to intersect. So what that means is that in order for two lines to be parallel, they have to be on the same plane. These two lines are on the plane of my table. Okay? If they intersect, they have to be on the same plane. They are on the plane of my table. But for them to never intersect and not be parallel, as in skew, they have to be on different planes. So it's about planes. All right, so same plane, parallel, same plane. I'll just write that on here. Coplanar. Coplanar means lines on the same plane. Intersecting lines must be coplanar, not coplanar. I should say non-coplanar. That's the official way to say it. All right, and then you could think about this as two-dimensional. Two-dimensional. Skew lines only happen on 3D diagrams. Okay, so this is a three-dimensional diagram right here. If you can tell that the planes T and U are two planes, you know, kind of that are horizontally stacked on one another. And then this line K is actually piercing down through both planes. And then these lines N and M are on the top plane T. Okay, so we have a new marking here. Lines M and N are parallel. And what that looks like on a diagram is this. They put an extra set of arrows kind of in the middle of the lines. And so when you see that, that means parallel. Oh, and the symbol for parallel is basically just a little pair of parallel lines. All right, so if I wanted to say that lines N and M are parallel, it would look like this. N is parallel to M. All right, skew, the pair of skew lines. So, I mean, this dot is kind of a giveaway that lines K and N are intersecting, so they can't be skew, but lines K and M are skew. They're on different planes, and they don't intersect. All right, planes T and U are parallel planes. There is no markings to show when planes are parallel, but I think this is supposed to be a statement. Planes T and U are parallel, so what you would write it as is this. T is parallel to U. All right, and remember, T and U, capital letters in the corner of planes act as a label. So we're not naming these planes by their three-letter name, we're naming them by their label. Are intersecting, which we can see by the dot. Can you tell if they are also perpendicular? And you know, even though the planes are parallel, that doesn't force this line to be perpendicular. It kind of looks like it's going straight down through the planes and it would be perpendicular, but unless they give you a little boxed off angle or they tell you, then no, you can't tell. All right, and is there a plane determined by lines K and N? And this is kind of a piece of information that we didn't get, I think, back in the last chapter, but Typically, when we were naming planes, we named them with 3 points, and we said, okay, it takes 3 points to name a plane. The other way to name a plane, there's a couple of other ways, is to intersecting lines or to parallel lines. So if you could picture, you know, a plane that you could put on top of these parallel lines right here. Let's see, do I have a piece of scratch paper here, right? So here's a plane, right? 2 parallel lines would form that plane. If I had 2 intersecting lines, and I can have this plane would be determined by 2 intersecting lines as well. Okay, so the answer is yes, because they're intersecting. 2 intersecting lines determine a plane. Okay, so now we're just going to work on interpreting a 3-dimensional diagram. So this is a perfect cube, which means we're going to assume that all of these corner points are perpendicular. They all meet at right angles. And then I put this into a sleeve so I could mark on it. What lines are parallel to AE? All right, so here's AE right here, and I'm going to just go ahead and make it longer. All right, so I put this, like I said, in a sleeve. So now I had to turn off the light because there was such a glare. So I've got all these weird shadows on here, but let me see. I'm going to grab a different color. BE, DH, and CG. Those are the 3 lines that are parallel to AE. Okay. What lines are skew? I'm going to erase that now. All right. What lines are skew to AE? And there should be 4. Okay, so now we're looking for 4 lines that are not parallel, but also do not intersect AE. All right, so that would be lines CD and GH. Those would be 2 skew lines. And then line BD and FH. Okay. So again, they just have to be skewed to line AE. I know like these 2 are parallel to each other, but we're looking for their relationship to AE. All right. And now we'll go ahead and erase those. We'll look at what lines are perpendicular to AE. So in order to be perpendicular to AE, they have to intersect AE. That means when I draw them on here, they have to actually cross over the red line. So this would be 1. And I know it's not marked, but we're assuming right angles at all these corners because it's a perfect cube. So that would be like a right angle there and there. And then you would have 2 more here and here. Notice those 4 lines all cross over my AE line. So we had AB, EF, AC, and EG. All right, and then what planes are parallel to plane CGH? Okay, so we're not really dealing with this line anymore. We're just going to go ahead and highlight or shade in plane CGH. So here's CGH. So remember, it's more than just 3 points, right? It's naming the whole plane, and it includes D, even though it didn't name D. So that looks like the bottom of the cube, which means the plane that would be parallel to it would be the top of the cube. All right, so that would be plane. And then pick any 3 points that you want and put them in any order. I'll just say A, E, B. Okay, I'm on the back side. Being able to identify these angle pairs, there's 4 different angle pairs back here, ends up being pretty important. So we should have an extra diagram that we can label, but we don't. So we're going to just kind of work with this diagram right here and get some initial labeling done. This line right here that crosses over the other 2 lines is called the transversal. Okay. And then on these diagrams, when the transversal crosses over these other two lines, we generate 8 angles. Some of them are interior and some of them are exterior. So these angles right here, 3, 4, 5, and 6, those are considered interior on your diagram. All right, interior angles. And then angles 7, 8, and 1 and 2 are considered exterior angles. Exterior angles. And 1 and 2 as well, exterior. Okay, so being able to identify alternate interior angles. All right, so what alternate means is on alternating sides of the transversal. And interior means we're only going to be looking at the interior angles, 3, 4, 5, and 6. All right, so I'm going to just pick one of them. And I'm going to say, I'm going to pick angle 3. I'll just put an arc on it. All right, so its alternate interior angle pair is angle 6. It's on the alternating side of the transversal and it's interior. It's not 4 because 3 and 4 already have a defined relationship. They're called a linear pair. So angles 3 and 6. All right, and then angles 4 and 5 are the other pair. All right, and you can see there's going to be 4 pairs of angles that we're going to have to be able to identify. So the little trick of the trade is to outline a pair of angles and see what letter gets produced. Because on this diagram, I know these are easy to see, but when the diagrams get more complicated, sometimes finding the angles ends up being a lot harder. So I'm just going to pick angles 3 and 6. So the way that this works is you trace over angle 3 and you trace over angle 6. That just means you outline the sides. And then if they meet up by extending the sides like this, don't go past the vertex, but just meet up in between if they meet up. You've created a letter, all right? And so the letter that is associated with alternate interior angles is a Z. Okay, list all pairs of alternate exterior angles. Okay, so alternate exterior angles are on alternating sides of the transversal in the exterior position. All right, so angle 1 would be alternate exterior pair with angle 8. Angle 2 and angle 7 is the other pair. So if you pick a pair of these angles, I'm just going to pick 1 and 8, right? When you extend the sides, here's angle 1. They just keep going further and further away from each other. Angle 8 goes this direction. So they don't ever join up and make a single letter, right? Don't join in between these two angles because then you'd have to go past the vertex to extend the sides of the angle. So these make V's. Sometimes I call them opposing V's, but that's the letter shape that you look for. Sometimes these get confused with vertical angles because they kind of look like vertical angles, but just keep in mind that angles 1 and 4 are vertical. Vertical angles have to share a vertex, and vertical angles only get created with 2 lines, right? These angle pairs are all getting created with 3 lines. All right, corresponding angles. This is the one that has where there's 4 pairs of corresponding angles. So corresponding angles are the angle pair where there's 1 interior, 1 exterior on the same side of the transversal. You can write that out in words. I think I won't write it though. 1 interior, 1 exterior, same side of the transversal. So just pick any angle to start with. All right, they're all going to be paired up with something that would be corresponding. So if I picked angle 2, that's an exterior angle. Now I need its corresponding angle is going to be angle 6. Notice it's interior and it's on the same side of the transversal. It's not 4 because 2 and 4 again are a linear pair. All right, angles 4 and 8 is another pair. Right, 1 interior, 1 exterior, same side of the transversal. Angles 3 and 7 is another pair, and angles 1 and 5. Okay. What letter is associated with this angle pair? So we'll pick any pair and go for it. Okay, so I'm going to just choose angle 3. Here's angle 3, and its angle 7. Okay, so now notice if you extend the side of angle 3, it is going to bump into angle 7. And you do generate a letter. Okay, so this one is backwards, but it's supposed to look like an F. And that happens with all of the corresponding angles. They make an F shape. Okay, and then the last angle pair is called consecutive. And I wish it was not also a word that started with C, because corresponding and consecutives people always mix them up. All right, so the rule with consecutives, they are an angle pair, interior only, same side of the transversal. Okay, so angle 3 and angle, here's 3. So same side of the transversal, interior only. That forces it to be angle 5. All right, angle 4 and angle 6 is the other. All right, so if you trace over one of these pairs, I'm just going to trace around. Here's 4, angle 4, right? And here's angle 6. So if you extend the sides of the angle, don't go past the vertex. They join up and make a single letter, and it's supposed to look like a C. Okay. Okay, and then just to finish off, we'll practice identifying some angle pairs for a little bit. And so the thing that makes these harder to identify is that the diagrams are now more complicated, right? There's more than just 3 lines on the diagram. So what we will do first, and I encourage you to pause the video and do this on your own first and see if you can get, and then just tune back in to check. But if you outline angle 2, and then you outline angle 4, and you extend the sides to see if they join up, don't go past the vertex. All right. They join up, they make a Z shape, which means that this is a pair of alternate interior angles. And you can see that this line on the side here and this line on the side here, those were extra lines on the diagram. Unnecessary. You could totally remove those lines and your angle 2 and 4 would still be sitting on your paper. All right. Angle 1 and angle 5. Trace them. If you extend angle 5, it does bump down into angle 1, so those make the F shape. So these are called corresponding. Okay, and angles 3 and 4. And again, just ignore the extra lines on the diagram. They don't exist for us. So here's angle 3 and here's angle 4. All right. If you extend these sides, they continue to move away from each other. All right. Don't go past the vertex. So this is never going to get traced over. They're never going to connect up. These are the opposing V's, the 2 V's. So these are alternate exterior angles. Okay, and example 2 here. Which angle pair is shown? So we're talking about the numbered angles. So if you trace them, there's angle 1. Angle 6, they do join up. They make the classic N or Z shape, I guess. So that is alternate interior angles. Okay, which line is the transversal? So sometimes this is harder to see, but we're going back to the original 3-line diagram. And this has more than 3 lines on it. So we need to figure out where our 3 lines are. So here's what I do. The lines that you traced around to trace around your angles, extend them. And if I had wide out here, I would try to just wide out. These lines have absolutely no impact on angles 1 and 6. You could remove these top and bottom lines and angles 1 and 6 would still be sitting there on your paper. Okay, so this helps us to see that line AC is the transversal. And which lines are not involved in angles 1 and 6 at all? AB and DC. All right, and diagram right next to it. Pause your video, see if you can answer them first. But what angle pair is shown here? So trace the angles. Here's angle 1 and angle 2. Okay, so notice if you keep extending the sides of this angle. These two angles never join up, right? You're never going to trace over that little piece in between them. Okay, so that makes these alternate exterior angles. They make the opposing V's. The transversal. All right, so now I'm going to confuse things because I am going to trace in between them. But if you, I'm going to use a different color pencil. So if I extend these to the three lines that are making these angles, here's 1, 2, and then this is the transversal, right? This is the line that these two angles both have in common, even though I said don't shade that CD portion. If you look at, this is the line that actually is the transversal. Okay, so the transversal, I mean, it's got 4 points. Pick any 2 points you want to on here. I'm just going to use B and E to name the line. All right, and which lines are not involved with angles 1 and 6? What are the lines you could remove from the diagram and you would still have angles 1 and, oh, I have 6 here. It's supposed to be 1 and 2. 1 and 2. So you could have A, B, and E, F. All right, so good luck identifying your angle pairs.